All right, how's everything going?
Good.
All right, so questions? Doing well on the ODPs? So 403 is posted. Make sure, suggestion, make sure that your Canvas is set up to give you notifications immediately and opposed to once a day or once a week, because I won't give you new assignments over the weekend that are due on Monday. Okay, I'm not going to do that. If I give you a new assignment, it'll be during the week. But I released ODP 403 this morning at like 8 something, and it should give you a notification about that to let you know. So if I don't mention it in class, it should tell you right away that there's a new assignment posted or a change to an assignment or an announcement. But you got to set it up to do it immediately.
And ODP 403 is due tomorrow?
That is due tomorrow morning at 8. But if you do it today, then it's not technically making you work on the weekend, so you don't have to think of it that way. And so 403 is a shell script that's going to read some input. Okay, it basically reads an integer from the user, multiplies it by 2, prints that out. But make very sure that you don't have any other output. So if your script says, please enter a number, you're going to get 0 out of 10. Okay, because it's an automated system. It's expecting you to just type in a number and it'll print out twice whatever that number is. So so these things are very particular. And so it's also an exercise in sort of following a program specification and making sure that you're doing everything it asks and then nothing else. So an additional comment that started to come up, be careful what you name your scripts, okay? Stay away from existing program names and stay away from the word test, because test is actually a built-in command in Unix. And if you write your script and you call it test and you say test, it may work for you, but when the assessment says test, it may get to the built-in test command. So if you're positive that your script is working right, double check to see if maybe it's the name of a built-in command, because that sometimes is what's going wrong. And if you say where is in the name of a command, it'll tell you where that command is located. For example, there's a test already in user bin test, and that tells you that, hey, there might be some confusion here. Whereas PA1, there is no PA1 on the system, so that's a good name for me to use. Or ODP 403 or whatever. If you call your program ODP something, you're pretty much safe. If you're doing your ODPs and it's not working for you, right, so you say assess ODP 403, ODP. No, I don't have. All right, so I'm positive my program's correct, but it's giving me 0 out of 10, right? Here's what I suggest you do. Do a cat on your program. Do an ls-l on your program. And, yeah.
Go turn ice down.
Oh, yeah. All right, so run your assess command, right? And then do a cat on the name of the program just to show the contents of it. And then do an ls-l on the program so we can see other information about it. And then come up here and with your mouse just copy all of that. And then go in here and whatever your favorite mail program is, and just paste all of that into an email message. Okay, that's easier than screenshotting, because screenshots are only one at a time. And it gives me most of the information I'm going to need to be able to help you. Right, I can see your source program. What I can't see when I look at the logs is, did you say assess try, or did you say assess something else try, or was your program not executable, and so on and so forth. The more information you can put in there, the better. And copy and paste works great. It's kind of old school, but it's a really powerful mechanism for sending information like this, or for copying files from machine to machine and so on. All right, so I said we were going to talk about arithmetic comparisons and looping. So let's run through those. So the basic syntax for an if statement, right? If space bracket bracket space, and we can say something like $ variable inside double quotes space equals equals space, and maybe another variable or a particular set of characters or something. Right, so that's the form we were using last time to check for secret codes and so on. Suppose you want to know if the number that the person typed in is less than or equal to 3, right? So same thing, it's just this part in the middle that changes. So you can say $ variable dash less than or equal to 3. Right, so dash LE is less than or equal to, and you can do less than, greater equal, equal, and not equal.
Is that slash E?
LE, less than or equal. And it's just the first letter of each word, greater, equal, greater than, and so on. So let's try this. All right, so enter a number less than 4, read a number. If number is less than 4, good job. Otherwise, not such a good job. So, I guess I have to save this. So what do I have to do before I can run compare? Yeah. 755, good. So compare, enter a number less than 4. There we go. Enter a number less than 4. That's not less than 4. So your choice is less than, equal, greater, equal, etc. So let's just do comparison of integers, which will be useful for the matchstick picking game. All right, so one more thing we need for general purpose programming, and that's looping. And let's see how a while loop works. That's all there is to it. So while bracket condition, do, and then the things you want to do in the loop, and then done to indicate the end of the loop.
Why isn't it while backwards?
I don't know, because I think even the people who were coming up with this weren't that extreme.
Is there a version of do like in C?
Say what?
Is there a version of do like in C?
Like a do until?
Yeah.
I believe so. And there's also a for statement. But I'm going to try to stick to whiles. Again, because I want the emphasis to kind of be on algorithms. But yeah, there's other versions of looping.
And you can stick other command. Can you stick other commands to the condition of the while loop, like read? And
I don't. You could, but probably not in the way that you're asking.
okay.
But you can put in expressions. You could say, well, $, parentheses, x plus 1, close paren, dash equals, etc. Right?
Right. Do you need parentheses between do and done?
No, do is just a 2-letter keyword. Done is 4 letters. Those go on their own line, and then anything in between those is the body of the loop. And this is all kind of analogous to C, right? So in C, we'd say if parentheses, expression, curly bracket stuff, curly bracket, right? So the double bracket with the spaces on either side is like the parentheses, that's like that parentheses, then is this opening brace, and phi is the closing brace. And the same thing happens with a while loop in C. What does it look like? While, parentheses, condition, opening brace, stuff, closing brace. So it's kind of like C, just with picky syntax. So we already did flowcharts for printing the numbers 1 through 10, right? Let's code that up. So we'll set number equal to 1. So this is the next number to print. So I'm initializing number to 1, and I'm saying as long as number is less than or equal to 10, let's print out that number. That's the echo statement. And then take the value of number, add 1, store that back in number, and we'll go back up to the top of the while loop. Does that make sense? So everything that you know how to do in C, or whatever languages you've programmed in, right, really maps pretty directly into shell scripting. The hardest part is probably just the quirks of the spaces and things going on separate lines and so on.
Do the less than or equal to commands treat not numbers as 0, or do they?
Most likely. But let's see. So yeah, haha turned out to be less than 10. Yeah, so it looks like it's treating it like a 0. All right, questions about that? That's kind of all there is to it. So with that, let's take a look at programming assignment 1. So this is due October 5th, which is a week from today. Oh, and by the way, I'm giving a seminar a week from today at 12 o'clock on the 5th. I'm going to do a STEM seminar and basically talk about my life of research, or the research that I've been doing like most of my life. But it's intended to be kind of a general audience talk, so you've got more than enough background to grasp everything I'm going to talk about, because you've got all these other courses in your background. But hopefully it'll be interesting. It's talking about like alternative views of computing and how rocks can do computation and how karma and space and time are all related. Yeah.
How long is that and where will it be held?
So I got to check that myself before next Friday, but I believe it's in the next room, not the one connected to this, but the one like right around the corner there. Hopefully it's not in here because I got a class at 12:30. I think it's an hour, so 12 o'clock to 1, which means if you're in 2:15, you get to miss the first half hour of class, or you can come into the seminar and listen to it. But yeah, so hopefully that'll be interesting. And I think they provide food, so that's even better. All right, and while we're talking reminders, engineering club meeting today at 12 in room 126 if you want to. If you haven't checked out the club already, I definitely recommend it, if for no other reason, because it's a good way to sort of get SLP ideas, or you want to do software SLP but it's got a hardware component. You might find someone who's got to do a hardware SLP and needs a software person, and you might find someone to collaborate with, and it's worth checking out. And I don't know if they have pizza today, but usually they have pizza, so that's
Room
bonus.
126, you said?
Room 126, yeah. No pizza today, okay.
Don't come.
Don't, no. So, but is there going to usually be pizza, you know?
Not next week, but after that.
After that, okay, cool. All right, so programming assignment 1. So first and foremost, this is a shell script, okay? If you've already written this in C, that's okay, because programming assignment 2 is going to be the same program, but it's going to be written in C, okay? So you're going to do this twice. You'll get to know this algorithm really well. So it's the stick picking game that we started working with a few days ago. And you just run the command with the name of the script, which is stick. Okay? Make sure you call the command stick. Don't call it my stick program or something like that. Okay? Don't make me think too much when I'm grading these. So stick. You run the program, first thing it should do, say hello to the user, right? Tell them what's going on. What does this program do? We're about to play a game where we pick sticks. You can take 1, 2, or 3. The person who picks the last stick wins, right? You can insult the user and say you're going to take them down or whatever. I don't care. Ask the user how many sticks to play with, okay? And it's got to be at least 10 sticks. If they say they want to play with 5 sticks, say, nope, you can't do that. Ask them again. If they say, I want to play with -7 sticks, say, nope, that's not valid. Ask them again. Ask them as many times as it takes, okay? Until they put in a number bigger than or equal to 10. And then ask who should go first. And they should type either a C or a U, followed by enter, to indicate the computer or the user goes first. And again, if they type in something different, tell them that's not a valid answer, remind them what their options are, go back and ask again. And this goes indefinitely until they put in a valid integer bigger than or equal to 10 and either a C or a U. Okay, then the game starts playing. And depending on who's going first, right, if the user's going first, ask them how many sticks they want to take. If the computer's going first, use your algorithm to decide how many sticks you're taking, and then say, you know, the computer takes 1 stick or 2 sticks. And then tell the user it's their turn and ask them how many sticks, and keep playing through until the last stick has been taken, and then announce who wins. you want to show the set of sticks after each player's move. So every time that you or the computer takes a stick, print out a set of pipes, right? For 1 pipe per stick. So if there's 17 sticks, just print out 17 of these vertical lines to show the pile of sticks. So just a visual thing. So that's the set of pipes. And at the end of that, put the number of sticks in parentheses. Right, so pipe, parentheses 5. All right, illegal moves. If the user tries to take something other than 1, 2, or 3 sticks, remind them that those are their only options. If they make a second illegal move right away, the game's over. They're disqualified. Okay, you can say you're not playing fair, you lose. If they put in a correct choice that second time, right, then continue playing the game. If they put in an illegal number of sticks in the future, tell them that's illegal, ask them again. If they put in a correct number, continue. If they put in 2 illegal moves in a row, game's over, they're disqualified. Is that clear? All right, that's all the mechanics of the gameplay, that's all that it has to do. The algorithm we've already talked about, right? Basically you want a multiple of 4 sticks left when it's the user's turn. So you pick n mod 4 unless n mod 4 is 0, in which case you pick 1 stick. All right, other requirements. So got to be a bash script. Well, this isn't a requirement, but make frequent backups, okay? Copy your code into another directory so that if you accidentally delete your program, that's not the only copy you had, right? Or if nothing else, print it out periodically, right? If you want to go old school. But make sure that you don't have just one copy of your code that you're working with and editing.
How do you make backups?
So good question. All right, so I'm sitting here in my 224 directory and I've got a few programs that I've written. Here's the easiest way to make a backup. Make yourself a directory, and I would call it backup. Okay, so make dir is the command to create a directory. And so if I look now, there's this backup directory. And if I look in there, it's empty because I haven't put anything in there. Okay, every now and then, you can just say copy looper to backup. And now if I look in my backup directory, I've got a copy of my program. So now I'm editing looper and I fall asleep with my head on the keyboard and I do some stuff like this, and I do a lot of stuff in my sleep, I guess. And so I wake up and I start going to edit my program and I'm crushed because my program's gone, right? You've got a copy in the backup directory, right? So I can say something like cat backup / looper. There's my program. It's still safe. And now you can copy backup / looper to here. And now I can edit looper. But if that happens, if you lose your file and you've got a backup, be really careful what you do from that point forward, because if you erase that backup copy, you've lost your backup. So take a breath and take a walk and make sure you don't do anything you don't want to do. And you can copy star to backup, and it'll tell you it's not going to make a copy of backup and backup, but it'll copy everything from this directory into this backup directory. So that's a pretty quick way. If you're running on your own system, if you have a Linux setup or a Mac or something, just copy your directory off to a flash drive, and that's a nice sort of off-site backup. And we'll talk about Git maybe next week, probably next week, and that's going to be the best way to save copies of your work, because then you can push it off into the cloud and have versions. All right, got to have comments in your script. Okay, your script's going to be fairly complex, particularly compared to what we've done so far with the ODPs. I want comments in there, including a block of comments in the beginning. Okay, and those should have your name, the course, the date, the assignment number, and then in your own words a description of what this program does. Okay, so don't just copy and paste the assignment and put a bunch of number signs in the front, okay? Paraphrase it, describe for the reader of your program, what does this program do? And it doesn't have to have all of this detail in it, right? But a couple of sentences, right? This is a stick picking game, each person picks sticks, 1, 2, or 3, you're trying to get down to 0 or something like that. All right, let's talk about archive since we're here. I don't know what PA1 is. Oh yeah, PA1 was this awesome program. All right, so I've got my PA1 finished, okay? Let's talk for a minute about archives. So this script is probably going to be a single file, okay? If you get like really super fancy, you could like split it into separate files and link them together, but you don't have to do that, and I don't recommend it for now. But with C programs, sometimes we have multiple files. We might take different functions and put them in different .c files. We might have an include file and so on. So typically, our projects might consist of a set of files. And we don't want to have to submit 6 different files to Canvas for grading, right? So what we'd like to do is take all of these and put them into one file. Think zip, okay, if you use zip in Windows. Zip compresses, but it also takes a bunch of files and throws them into a single thing. And then that single thing can get uploaded. So on Linux, the way we do that is the command tar. So I'm going to give you 3 tar commands. And if you use these in this way, your life will be great. And if you use them in even a slightly different way, your life might get more interesting. So tar cvf, archive name, and then a list of files separated by spaces. Okay, this creates an archive. And there's no dash in here. Okay, so CVF. This says create, this says be verbose, tell me what you're doing, and this says I'm about to tell you the name of the archive file. And so this is the archive file name. And this is the list of files you want to put in the archive. So if I want to put looper into a tar file, tar cvf my upload, I'm just going to call it my upload.tar, and I'm going to say looper. And it's telling me that it just added looper. So now if I do an ls, I have this file called my upload.tar. And that contains looper. All right, so if I want to see what's inside the contents of an archive, look at the contents of an archive. This is tar tvf, archive name. So same thing, except it's a T for table of contents instead of a C for create. So if I say tar tvf myarchive.tar, it shows me what's inside there. Well, there's one file inside, it's called looper, and it shows me when it was created, 1025, the date, how big it is, 154 bytes, the owner and the group, that's me, and the permission flags on it. So all this information is stored in that archive. Now suppose that my project contained compare and looper and PA1. I can put those all into a single archive. So tar cvf, the name of the archive, compare looper PA1. And it adds all 3 of those. So now if I want to look at the contents of my archive, it's got 3 files in it. And this is another way to do backups, but this is how you're going to submit your assignments. You're going to submit a tar file. But this is convenient for backing up because I have a single file, my upload.tar, that contains all 3 of these programs. So if I just copy that to my backup directory, I've backed up all 3 of these programs.
And this is, and the my upload tar is what you assess when you go into the assessment platform?
No, nothing to do with assessment. Assess only takes an actual program. But this is what you're going to upload at the end of PA1. So after you've upload stick.tar to Canvas. So instead of my archive.tar, make a tar file. So here's the command, tarxvf stick.tar stick, to make an archive named stick.tar. And then upload stick.tar to Canvas. And then to make really sure that you did everything right, here's what I suggest. When you're done, go back to Canvas, download stick.tar, and extract your script from it. And the way you extract is tar. That should not have a dash in it. Ignore that. It's not there. I will fix that immediately. So tar xvf archive name.
That allows you to see all the programs?
TVF lets you see all the programs. XVF will pull the programs from the archive and drop them in your current directory. So let's suppose I've deleted my programs and all I have is this myupload.tar. So I can do tar TVF. I can see it's got 3 programs inside there. If I want to pull those out into my current directory, I can just say tar xvf. And now those are back in my directory. And they're still in the archive. It just reads a copy.
Can you just type in the stick.tar into Canvas?
There's an upload option. Eventually. Maybe. Well, anyway, if you look at PA1, there's an upload button that will let you submit your assignment. What you want to submit is that stick.tar file. And that's the only type of file it'll accept. Yeah?
How would we get our files, our PR files from the server to the computer?
So I think our web connection is down. So the way that's written up in this how-to guide is to use SFTP. There's other ways to do this, but this way will always work. So transferring files between Linux and your own system. So if you're on Linux or OS X, use SFTP. If you're on Windows, I recommend WinSCP, right? And it just brings up a drag and drop. It's like old file manager from 3.1. Linux on one side and Windows on the other. You can just move files back and forth.
So when we get to Canvas, what's the upload option?
Well, I was trying to get there and it wasn't cooperating. Let's try it again. There should be a button that says upload. Submit assignment. So it'll ask you to choose a file, and you can go and browse your directory and find a file. find stick.tar, and it'll go ahead and upload it. Submit assignment to actually do the upload. Make sense?
So you save it to your computer using SSH?
Using WinSCP or SFTP, depending on your operating system. And check that how-to guide for details. All right, other questions about this? So suggestion, right? Nail down the algorithm, and we'll take a few minutes here at the end and work on some flow charting for this program. Work on the algorithm. Make sure you understand on paper what you want your code to do, and then start converting it into Bash, writing some statements, and we'll talk about that next. So write your Bash script, test it, get it to work. Once you think it's working, test the heck out of it. Okay. I don't mind if you find a friend and say, hey, can you try to break my program? Okay. I don't want you looking at each other's source code, but I'm okay if you want to test each other's code. So say, hey, try to break this and see if they can get it to blow up, right? And you can do the same for them. And this is hard, right? This is a whole separate discipline, because we write code, we know how it's supposed to be used, that tends to be how we test it. We're not going to put in a number 5 if we know we need a number between 1 and 3, right? But I'll put in a number 5 when I'm testing it. So test it, make sure it works. If it doesn't, do some debugging. Go back, make sure it's got good comments inside, and then go ahead and deal with the tar file and go ahead and do the upload. Let me show you what you don't want to do. So here's my program looper. So don't do this. Tarxvf looper. Cowardly refusing to create an empty archive. Okay, so it's going to save you from yourself here. All right, so, well, okay. I can't get a good example together here, but don't forget the archive name. Okay. Because whatever you put here is going to get overwritten. Right? That's where it's going to try to write the tar file. And if you actually put the name of your program here, your program will get munged. Okay, this happens like way too often in this course. So backups, right? And after you've made your tar file, do a tar TVF and make sure it's got your stuff in there. And pay attention to errors. If it gives you an error, there's probably a reason. Don't just try something different. Make sure you didn't do something that you shouldn't have done. Because I always get a handful of submissions, and I look at the program, and it's not a bash script. It's a tar file, right? That got put inside a tar file. So just be conscious of, make sure you have an archive name there. All right, so how do you go about approaching this? Have you talked about modularization or modularizing code or breaking problems into smaller pieces, things like that? Keep that in mind, right? Yeah.
So we're able to do those loops inside loops.
You can have loops inside loops, you can have ifs inside ifs, you can have loops inside ifs, and so on. Pretty much everything is legal.
Is there an and or statement in this?
Yes. And I don't know if I remember it, so let's figure it out. All right, I'm just going to try it because because I honestly don't remember. All right, I think we guessed it. So if bracket, bracket, blah, 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 bracket, bracket, and then 2 pipes for an or, 2 ampersands for an and. And I'll tell you what, let's make sure, because that feels a little too easy. Yep, that's the way you do it. All right, cool. Thanks for asking that. All right, we got 6 minutes left. I don't think I want to split into groups and go to the board. So we'll probably play with some flow charting on Monday, and make sure we can nail this algorithm. So where are we going from here? I want to talk more about Unix. I know you used Unix in 121 and you're using Unix this week to like do all of this stuff, but I want to go through just some of the basic moving around the directories, making directories, copying, renaming files, things like that, just to sort of make sure we're good on that. But there's this quick start guide that gives you most of the basic commands. So editing, compiling, executing, redirecting output, and so on and so forth. So we'll do a quick review on that. I'll talk about GitLab next week, okay, because I want to get people up on the air with that. And it's good for backups, and sooner is better. So we'll go through some GitLab, and then we're going to start moving into C. Okay, and we're going to talk about initially some review of stuff you've done in 121, but I want to move from there into some of the newer stuff. So we're going to pay a lot of attention to doing input and output, moving towards doing file input and output. And you've seen a lot of that, but we're going to do it in some different ways that will be more powerful. And then we'll go on to PA2 after that. So your PAs will usually be 2 weeks. This one's different because we're starting at the end of week 1, so you got 1 week for PA1.
What's PA1?
That's the stick picking game. Yeah, programming assignment 1. Let me ask you a terminology question. So let's talk shell scripts. So we've got a script called try. So we'll leave the typo in there. So who are you? Nick. Hello, Nick. Okay, so this program, when I run it, it prints out a prompt and then it waits for me to type something in, right? And I typed in the word Nick, and then it continued like that. That's something that I'm generally going to call a program input. So program input. This is something you enter while the program is running. And that's what I just did. That's what you're doing with ODP 403, right? You run the program, the script, and it waits for you to type in an integer. But there's a different thing that we can do. Which is I could modify this so that instead of running it and then typing something in, I could say try, and I could just put some input on the same line. And when I run it, it says, hello, Nick. And that's something that I'm going to call a command line argument. So a command line argument is something you specify on the same line as the command itself. Something you specify when you execute the command. And in some cases, like ODP 403, you're using program inputs, right? You run the script and you type something in. But future ODPs, right, we're going to start working with command line arguments so that instead of typing it in once it's running, you just say try and you actually put something on here. And that's the input that it works with. And we'll talk about how you get to those command line arguments, but it's actually really easy. $1 is a special variable that's always equal to that first command line argument. So it's like saying $1, but it's always available. But we'll play with that next week also. All right, that's a good stopping point. So.